In this video, we're going to do some solid geometry sample problems. A cylindrical container with a radius of 5 centimeters is filled with water until the water is 5 centimeters deep. The water is then poured into another cylinder with a radius of 10 centimeters. How deep will the water be when poured into the second cylinder? So this is a volume question. So volume of a cylinder is pi r squared times h. We know that the volume of water poured into both cylinders is going to be the same. So we can set volume equal to volume. So for the first cylinder, we have pi times 5 squared times 5. And then in the second cylinder, we have pi times 10 squared times an unknown h. So now all we need to do is solve for h. We'll see that the pi's are going to cancel. We'll just divide both sides of the equation by pi. And then on one side, we're going to have 5 squared is 25 times 5. We're going to get 125 is equal to 100 h. So then solving for h, we're going to get 125 over 100. And that is just going to be equal to 1.25. So we'll get 1.25 centimeters. A sphere of radius 5 centered inside a cube touches each of the 6 sides of the cube. What is the approximate volume of the space found between the sphere and the cube? So to find that, we need to take the volume of the cube minus the volume of the sphere. So the volume of the cube is going to be side cubed, and the volume of the sphere is going to be 4/3 pi r cubed. We should be able to figure out the edge length of any of the edges of the cube because we have the radius of the inscribed sphere. So the edge length is simply going to be double that radius, so the edge length is 10. So now all we need to do is take 10 cubed minus 4/3 pi times 5 cubed. And when we do that on the calculator, we will get 476.4. What is the volume of a cube centered inside a sphere of radius 5 that has all 8 of its vertices on the sphere? We know that the volume of a cube is given by the equation v equals edge length s to the 3rd power. We're not given the edge length of the cube, but we are given the radius of the sphere, which we'll draw in here, which is equal to 5. If we double the radius, we'll get a diameter, but the diameter is also going to be a diagonal of the cube, and the diagonal is going to be of length 10. If we know the formula to get a diagonal, this problem becomes very easy. If we don't know the formula, that's okay too, because we can actually derive it by drawing in a couple of hidden right triangles and then using the Pythagorean theorem. So we have edge length s, and edge length s. We're going to label this first hypotenuse c. So to figure out c, so we get c is equal to the square root of s squared plus s squared. Of course, we should know very quickly that since both the edge lengths are the same, c should just really be s square root of 2. So now that we have that, we can derive the formula for a diagonal of a cube. So the diagonal is going to be c squared plus s squared, and then the square root of all that. So we can write that as, substituting in s root 2, we can write that in as the square root of s root 2 squared plus s squared. And that is going to simplify to s square root of 3. So s square root of 3 is equal to a diagonal. We know the length of the diagonal is 10, so we can set that equal to 10. So that's going to give us s is equal to 10 over the square root of 3. Now, to find the volume, we want to take s cubed. So volume is equal to 10 over the square root of 3 to the third power. We can simplify this further. I'll skip the simplification steps and just give the final answer, but we will get 1,000 square root of 3 over 9 for our final volume of the cube. The structure below is made up of two rectangular prisms stacked on top of each other. The bottom of the structure will be sitting on the ground, but the rest of the exposed surfaces will need to be painted. What is the area that needs to be painted? So this is a more involved surface area question. Let's focus first on the top prism. So the surface area of the top prism is going to be all the faces except for the bottom face, which is sitting on top of the other prism. So we have the front face and the back face, so that can be given by 2 times 2 times 2. We're going to add that to the left and right faces, which is given by 2 times 3 times 2. And then we just have the top face, and that is given by 3 times 2. Now, the surface area of the other rectangular prism, we know we don't need the bottom, so we can ignore that. So let's do the front, back, left, and right faces. So for the front and back faces, we get 2 times 4 by 4, plus the left and right faces, which is 2 times 6 by 4. Now, for the top face, we know that the top face is 6 by 4. However, we need to subtract the area of the bottom face of the top prism, since that part is not exposed. So we're going to subtract 3 by 2. And when we take all of that together, that should give us the total surface area that needs to be painted. So we're going to plug that into the calculator to get it all figured out. That will simplify to 124 square units. The volume of the right square pyramid below is 4 cubic inches. Given that the height of the pyramid is 3 inches, what is the area of one of the triangular faces of the pyramid? The volume of a right square pyramid is 1/3 a squared h. So we have the volume, so the volume is 4, and we can set that equal to 1/3 times a squared, and we don't know a, times h, which is 3. So that will simplify to, we can cross out the 1/3 and the 3, so that'll give us 4 is equal to a squared, or a is equal to 2. So now we have the edge length of the base of the pyramid. So from there, how do we figure out the area of one of the triangular faces? Well, for that, we need to draw in a hidden right triangle. So let's draw that in. We're going to call the hypotenuse of that hidden right triangle L, or the slant height. So now we know that one of the legs of this right triangle is going to be h, and the other is going to be a over 2. So we'll put that in as a over 2. So now we apply the Pythagorean theorem. So we get L is equal to the square root of a over 2 squared, or 1 squared, plus h squared, or 3 squared. So that gives us L is equal to 1 squared is 1 and 3 squared is 9, so the square root of 10 is going to be L. Now that we have L, we can plug that into our area formula for a triangle. So the area of a triangle is equal to 1/2 base times height. So the base is A, and the height is L. So we get 1/2 times A, which is 2, times the height, which is the square root of 10. So the 1/2 and the 2 are going to cancel, so we'll be left with the square root of 10 as our final answer. A lump of wax in the shape of a rectangular prism has the dimensions 4 by 4 by 6. What is the maximum number of 2 by 2 by 3 pieces of wax it can be cut into? So let's take the volume of the big piece of wax. So the volume is equal to length times width times height, or 4 by 4 by 6, which of course is 96. The smaller piece of wax, or what we're trying to divide it into, is 2 by 2 by 3, which is equal to 12. So now all we need to do is take the larger piece of wax and divide it by the smaller piece of wax. So we'll take the volume 96 divided by the volume 12, and that will give us 8. So the maximum number is 8.